So we've discussed many different ways to do integrals by hand. Now it's time to borrow some help, okay? We're going to talk about how we could use tables of integrals to do integrations. So what you see here is an example of a table of integrals, and I got it from integral-table.com. And you could see how tables of integrals help us. Okay, they give us basic forms of integrals. So, for example, over here, you'll get 1 over x plus a squared. Okay, where a is any general constant. Okay, could be any sort of number, and you'll get the form of the antiderivative. These don't include that plus c, but you have to include that. You also see some other common forms that you'll get where, again, a and b and c are constants. So you start with these general forms, or you put your integrand in this general form, and then you come and you take a look at the table of integrals, and you basically fill in any of the constants that you had in order to put your integral in the form of the table of integrals. And you could see here, I'm just browsing down, you got integrals with logarithms. And so these help us, okay? Now, we could do a lot of these integrals by hand, but we already got a lot of practice doing that, and now's the time to get some help from these tables of integrals. So let's do an example of how we would use tables of integrals. Suppose we want to evaluate this. Now we can do a u substitution using this form here. It will work, but let's borrow some help. So we take a look at a table of integrals, and the closest type of integral in the table looks like this. Okay, you could see here that if we take a to be 2 and b to be 9, okay, and notice here that the table of integrals imposes that b is positive, then we will get this form, okay? And pay attention to the sort of assumptions that are made, okay? A is real, but b must be positive. And so we'll get this, so this is the general form, and we just fill in the blanks now, basically that a is 2 and that b is 9, and we get our answer using table of integrals. Now, of course, that's not legit to do when you're actually learning integration by parts or trigonometric substitution or u substitution, but once you do, and then you've got a lot of practice, then you can start using these tables. Okay, let's look at another example here. Well, we start with this integrand. It's x squared plus 6x. And the closest sort of integral that we could find in our table of integrals is of this form. Suppose that's the case. Maybe you could find a table of integrals where it gives you a closer form, but suppose this is the closest that you could get. And you know that this integrand looks like this. Okay, and the antiderivative of that integrand looks like that. So, all right, we got to put our integrand in that form. This has x squared plus or minus a squared. This is a x squared plus 6x. So what do? We complete the square. Okay, we complete the square. We get this result when we complete the square, and then we do a u substitution with u is equal to x plus 3, and we end up putting our integrand now in the form of the table of integrals. We take the integral using the table of integrals, and we get this result. We substitute back u, and we end up with this final result over here. And this is basically how you use tables of integrals.